Exponents. So we're going to be working with powers, which is repeated multiplication. So we know multiplication is repeated addition. Powers are just repeated multiplication. So let's break down the parts of working with powers and exponents. So a power is a product of repeated factors. So again, we're going to multiply the same factor over and over again. The base of a power is the common factor. So the base will tell you what we're going to be multiplying over and over again. The exponent of a power indicates the number of times the base is used as a factor. And we've worked with powers before, so this shouldn't really be anything new. Our base here is the factor that what we're going to be multiplying over and over again. Our exponent is that little tiny number up in the right-hand corner that's telling us how many times we're going to multiply that number. We call the whole thing a power. And if we think about what we're doing with the base there, we're multiplying the base this many times. So it's just a shorthand way of writing repeated multiplication. I'm going to multiply again and again. Instead of writing it over and over, I'm just going to use a factor. I'm going to use a power. All right, so let's put this into application. What does it look like when we use it? Write each product using exponents. So I have -7 times -7 times -7, which is kind of a pain to write that out the long way. So since we're doing -7 repeatedly, my base becomes -7. Since I have -7 3 times, it's -7 to the third power. Please notice that frequently when I have things other than just whole numbers or counting numbers, we put the base in parentheses to show that that's the entire base, especially with a negative, which we've talked about before. With a negative, we want to put that in parentheses so that we know that we're doing -7 over and over again. Here I've got 3/10 times 3/10 times 3/10 times 3/10 times x times x. So I have 3/10 as a base, and that's used 4 times. So my base is 3/10, my exponent is 4. And I've got an x here as a different base that's used twice. So I have x to the second power. So we're just rewriting those as a power using exponents. All right, we're going to evaluate each expression. So we're going to look at each of these expressions and figure out what number are they actually representing, what real number are they actually talking about. So this is -5 to the 4th power. So I've talked about putting the base in parentheses here. So when we look at this one, order of operations says parentheses first. It says exponents first. So I'm only going to deal with my 5 to the 4th power. I'm kind of ignoring this negative for a minute. It's not really part of the power. So it's 5 to the 4th power, which is 625, and then I kind of slap that negative on the front. Again, if I thought about this as 10 minus 5 to the 4th, I would have 10 minus 625. So that should be a -625 there, not a positive 625. As opposed to this one, and make sure on your worksheet it looks like this. I'm not sure if I fixed it or not. We've got parentheses around the -5 and a 4 as my exponent stuck on those parentheses there. So this one means -5 times -5 times -5 times -5. We're repeating that -5 over and over again. A negative times a negative is a positive. That's one pair. And then my second pair would also give me a positive. So this would give me a positive 625. So please pay attention to the difference between these two. That's very important. All right, here I have -1/6 to the 3rd power. So notice that the whole thing is in parentheses. We tend to do this a lot with fractions also, because we don't want to make it look like it's only the exponent. It's only the numerator that has the exponent, and that we're ignoring the denominator. If I want the whole fraction to be the base, I really want to put the whole fraction in the parentheses. So this is -1/6 times -1/6 times -1/6. That's going to be a negative. 1 times 1 times 1 is 1. 6 times 6 times 6 is 216. So I have -1 over 216. Please don't try to slam this in your calculator. We can do this out. We can think about this, figure out what it means, and come up with a fraction representation. All right, let's talk about these vertical lines here. These are absolute value lines. They work like parentheses in that you want to do what's inside first and then worry about our absolute value symbols. And our absolute value symbols mean how far away is this number from 0. That's what absolute value really means. Most of the time you think about making a positive, but it really means how far is this number away from 0. So first I'm going to do what's inside. This does not mean make everything inside positive. That's not what it means. It means do what's inside here, then we'll worry about seeing how far it is away from 0. So -3 to the 3rd power, this is 3 to the 3rd power, which is 27, so that's -27 divided by 9. -27 divided by 9 gives me -3. Now that I'm done doing what's inside, now I'm going to think about the absolute value. -3 is 3 away from 0, so we come up with 3 when I simplify that. And my last one here, 9 minus 2 to the fifth power times 5/10. So I'm going to do my exponents first. 2 to the fifth power is 32. Next I'm going to multiply. 32 times 5/10 is 16. And I'm going to finish up by subtracting, and we come up with -7. All right, last one is a word problem. Now, we're talking about these nesting dolls here. Do you like my artistic rendition of the nesting dolls here? Don't hate me because of my artistic talent. So this is my artistic talent of these nesting dolls. So nesting dolls are, we start with a small doll, and the small doll fits inside the next one up, which fits inside the next one, which fits inside the next one. So they nest inside each other, which is why they get progressively smaller. So the largest doll is 12 inches tall. The height of the other dolls is 7/10 the height of the next largest doll. Write an expression involving a power for the height of the smallest doll. What is the height of the smallest doll? All right, so we've got 4 of them. So my first one is 12 inches tall. My next one is going to be 7/10 of that. So this is my expression for the second largest doll. The one after that is 7/10 of what the second one is. And then the last one is 7/10 of what the third doll is. So I'm just multiplying by 7/10 repeatedly as I go down. So to write this involving powers, I have 12 times, and this is 7/10 to the third power. The last part asks me what the actual height of the smallest doll is, so I'm going to do this out. So 7/10 to the third power is 343 over 1,000. I grabbed my calculator and multiplied that by 12. I got 4,116 over 1,000, which gives me about 4 and 1/10 inches tall for this smallest doll.